A very good morning to one and all present here. First of all, I request all the non-speakers to keep their mic on mute. Let the speaker complete the session, and we will have a separate question and answer round at the last. So, I, Abhishek Sharma, on behalf of Chaudhary Charan National Institute of Agriculture Marketing, Jaipur, welcomes you all to the Kisan Mitr webinar series on agriculture technology for marketing, organized by Chaudhary Charan Singh National Institute of Agriculture Marketing in partnership with Principal Scientific Advisor, Government of India. Chaudhary Charan Singh National Institute of Agriculture Marketing, Jaipur, is an autonomous organization established under Ministry of Agriculture and Farmers Welfare, Government of India, to cater various agriculture-related aspects such as training, research, consultancy, education, and agriculture marketing. CCS NIAM is also recognized as a center of excellence in Southeast Asia. Kisan Mitr Friends of Farmers is an initiative by Principal Scientific Advisor Office in partnership with Chaudhary Charan Singh National Institute of Agriculture Marketing. The objective of the initiative is to bring technologies to farmers and reverse migrants who have moved rural due to the impact of COVID-19. Under the initiative, more than 1,000 technologies have been identified which are supported by ICR institutions, NABARD, Ministry of Rural Development, ISRO, and Gates Foundation. On the supply side of the technology, there are innovators, entrepreneurs, researchers in academic and research institutions talking about their technology, and webinar participants being on the demand side, who are typically agribusiness enthusiasts, government functionaries, agribusiness companies, and agribusiness stakeholders who are keen in agri technologies. So, moving further, I would like to introduce our today's speaker, Manjunath, who is a co-founder and CTO of Three Stake Labs Private Limited. Three Stake Labs is an agri-tech startup that was started based on ideology of utilizing the new technologies to improve the growth of farmers. They believe that efficient agriculture marketing system is the prerequisite for enhancing and sustenance of agriculture growth in our country. Through technology and better marketing system that they are developing, they can achieve to make a farmer get a true remuneration for his produce. Better price encourages farmers to grow more produces. Their gadget is developed for the point of sale grain assaying device with most innovative technologies for accurate assaying and integrated with efficient and innovative programmable system on a chip which transfer the data to the e-portal. This provides an opportunity for the farmers to sell their produce early and fetch a better and fair price. While they are currently focused on building their best-in-class portable and handheld machines, they are currently assaying for 30 APMCs in Karnataka. The plan on developing more automated technology device adds on to our nation's vision of doubling the farmer's income. So our today's speaker about Manjunath, he is a tech-savvy entrepreneur and mechanical engineer. He worked as an incubation manager for 2 years and as an account manager for Japanese AI-based company. His experience in technology and his entrepreneur mindset has supported Three Stake Labs in building the product faster and reliable with the best cost to manufacture. As a Chief Technology Officer, Manjunath is accountable for all the technology directions, engineering, and deployment of business initiatives of Three Stake Labs. Manjunath directly owns all the aspects like strategic roadmap, team ramp-ups, vendor alliance, partner management, solution designs, architecture, and engineering and quality assurance of the product and services that Three Stake Labs are offering. So at last, I would like to invite Manjunath to take a session on new technology in commodity assaying. Over to you, Manjunath.
Thank you, Abhishek. Thanks a lot. So, good morning, everyone. I hope everyone's fine at this crucial time the nation is going through, and I hope everyone's safe and fine. And thank you all for joining in today's session. And I hope most of you all are also tech savvy and are much interested into
Please
technology.
switch on your video.
Are you able to see me?
Yeah, now it's fine.
Yep. So I was telling is that so most of you all should be a tech savvy and we're interested into knowing what all the upcoming technologies that are there. And so I am from 3 class. My name is Manjunath, and I am the CTO, so the technology brain behind this particular project. So I would like to take you around and see how this technology was, how a lot of technology combined into one particular product, and how we have been surviving in our business model that we have come up with. I'll be just sharing my screen in a minute, and I hope you guys. So Abhishek, can you guys see my screen?
Yeah, it's fine.
Awesome.
Just enlarge it and go ahead.
Yep. So yes. Three Stake Labs, to give a short description about Three Stake Labs, we are a Bangalore-based startup, and we are an agri-tech startup. We had a vision of taking and to reduce the pain of the farmers and seeing what can make a farmer increase in his income. Though through our past experiences of ourselves going and trading into mandis and being in the point where a farmer has been, we had seen the pain point of what a farmer has been going through, and we wanted to just be a small scratch and seeing how we can just increase a farmer's income and see that he's not being exploited in the current society. So this being said, Three Stake Lab was started in the vision of helping farmers, and we are primarily at the moment focusing on assaying and developing machines for assaying. And so the device that we have come up with, so we started in 2019, and we are around a 1 year old company. So we started in uh, a very while back, and with a lot of iterations, we have come up with what we are now. To go about and just see what our problem would be and what problems that the farmer would be facing at mandi. So after a farmer is grown his grains and then he is taking it to an APMC, a farmer is expected to give the best quality over there. But some farmers do it and some farmers don't do it. So depending on the quality that he brings up to the mandis, the value he gets for his grains are being decided. It is decided based on something known as assaying. Assaying is the quality check that is being done, and a small certification being given at the farmer's level, so that so that the traders can check them and bid according to the price. But to see how actual real life scenario would be is there would be huge number of laws that is being arriving at the mandis, and though the government is being setting up assaying labs in a lot of places, it's kind of applaudable. But considering the huge amount of laws that is being coming, we felt that it wasn't sufficient enough for to handle the amount of lot that is being come, and we wanted a solution that can actually be faster and to optimize the whole mandi operation that is being happening. To just have a look around, a few field studies we had been doing. This was done in Arcanet market in Karnataka, wherein the assayer is sometimes taking the Arcanet, just chewing it and telling the quality of it. And then the lab is how the view of this would be looking like, where he'll be having a lot of samples that is being collected, and then he checks them through physical inspection in a plate like this, and all the different damaged grains and stones and foreign particles will be kept separately, and based on weighing and percentage basis, the quality of the grains would be decided. And after these are being done, it will all be entered in a computer, and here you see how the lot is being taken. So it's kind of a very manual work that is being done, and a lot of steps that has to be done into entering it into systems. So most of the things are manual, and we wanted to cut short all this and find out a system wherein it could reduce the time that has been taken, because at the current scenario with a huge number of lots arriving, it takes 3 hours to 4 hours for a sample results to come out. And if it's a huge arrival that has been coming, a farmer, it's impossible for a farmer to even assay it on the same day. He might have to carry it on the next day, or sometimes he has to just sell it at whatever price he gets, because if it's a perishable goods, he has to sell it at a faster rate. So that's why assaying was kind of primary. And so we saw all this through, and we thought that a solution needs to be here. And we checked up in the market, though there are a lot of solutions there, we didn't find most of them to actually solve the problem that is there, because most of these has needs to be a sample needs to be taken from a lot and then has to be brought back to the lab. No matter how feasible the solution that are there was, what happens is it has to be brought back to the lab again, and there's a lot of exploitation happening. There is a lot of mistakes that happen knowingly, unknowingly. Because of that, the sample exchanges could happen, sample mismatches could happen, and most of the times the farmer might not even know if it's sample what he is done it is actually being assayed, and the value what is getting is there or what. So we wanted a solution that could be a point on sale basis, wherein the assay just goes directly to the farmer's lot, and if he can assay it, what happens? And that is what we have built up with, which we call it as a smart grain assayer. And a device is what a proto of what device is what it is like this. And it's like you can see it's a very small that can be held in your arm like a drilling machine. It's as big as a drilling machine, and it can be carried around in the yard wherever it is, into the remote corner of the yard also. And it can be assayed, and the time it takes for a sample to be collected, the assaying results could be out. uh, so that's what it is. So the quick time turnaround time is the first USP for our product. The time it takes for a sampling could be 30 seconds to 1 minute. Assayer has to go from the lab and then go into the lot and do the collection of sample in the methods that he is opted for. And by the time that is it, this device can directly be plunged into the sample, and it'll do its assaying right then and there. And the assayer would be carrying a small printer with him, and he would be getting the slip for the assayed value directly to the farmer. He can give it out. So the time it takes for the entire assaying process, it would be like 1 minute to 1.5 minutes. That is like 1 minute 30 seconds for the entire assaying process to be done. So right then and there, it could be solved up. And there is no point of taking the sample back to the lab, getting it assayed, then uploading it in the portal, because the assay will have a phone that is connected to the device, and he would be entering the data of the farmers right then and there, and it would be all automatically done. So this will be a non-destructive based sampling method, wherein the grains that is being taken as a sample would be given out to the farmer, because we are using something known as image recognition, image processing technology. Because of that, even the sampling, in the name of sampling, the farmer might not have to undergo losses, because a lot of people take up a lot of samples, and then god knows where the samples goes. And sometimes there are other people who also say in the name of sampling they take up a lot of samples and then just go, and there's a separate team of people who are just there to collect samples and live up. So these type of things can be avoided, and the farmer might not go into such type of losses, and it's a non-destructive based sampling, so the grain just comes back to them. And with a lot of technologies that is going through in this also induces artificial technologies, where a lot of feedback based system is being implemented into it. Innovative dashboard is being put up. So not just from the assayer point of view, but from the higher authorities point of view also, they can see the quality of grains that have been come up, the quality of grain that can be expected to come up, and the quality of grains that are being assayed, and the amount of assaying that is being done. It's all being done through intelligent artificial intelligence process, and through a machine learning process. All these are being done through a lot of sensors and arrays that have been incorporated into this device. And our backend is kind of directly integratable with Boomi, Beledashak, and through this, through API shared model, it can be linked with REMS portal, ENAM portal, Boomi, other portals that are there, and a push-pull type of API sharing model can be done, so that instead of doing all the manual work or having multiple system, instead of having multiple systems and entering data, so directly one system would be enough for the whole process to be done. So this is a solution what we have come up with. And and uh, sorry uh, so it is also IoT based device, because it needs to have a cloud computing connection between the cloud, and all the data has to be pushed right directly into the cloud at a very faster rate. It has got a very sophisticated IoT device into it inbuilt, so the data could be transferred at a very faster rate to the cloud. And so the commodities this particular devices can do, and the parameters that this particular device would be doing is primarily on moisture, foreign matter, admixture, damage pulses, and weevil particles. And at the moment, we have optimized the device to do for 8 grains, which are ragi, tur, moor, maize, safflower, soybean, paddy, and urud dal. And to keep in mind that this device is kind of a modular device that we designed initially in mind. So that not just for a specific grain or specific product this has to be done, but it has to serve a purpose for a large number of audiences. So because of that, this particular device can be upgraded to other grains also, and it's not just limited to this. We are working on other grains, and on need to need basis and requirement basis, we could also add up other grains into this particular list. And most of these physical parameters could be assayed through this device. It's a very modular device as we have built, and it's a small device we did during a testing process. I would just like to show you guys. So here you see it's an app at the phone the Assayer would be having, and he would be entering the data of the farmer, the farmer's code, his phone number, the logs he has got, all these sort of data. And after these are being done, if I just skip, he would be selecting the grain he's doing it, the grain he does it, and then he will be connecting it to the device. And the moment he clicks on start assaying, the device would eventually be sucking up all the grains that is there, and through non-destructive process it would be doing all the analysis through all these circuits that have been integrated into it. And after we have at the moment taking half kg of grains for the sampling that is doing, and after half kg the device would eventually stop. So if you see, it's stopped, and then it would take up some time to do its to do its backend processes. It would take a kind of a minute or two. So I'll just fast forward it. So after all the processings are done, it would give up the result to the farmer, and all the parameters I had mentioned previously, you see, it would be mentioning with the farmer's name. And the moment he clicks a button, the message would be sent to the farmer with his value, and he'll also be getting a printed slip of the same parameters that he's got. This kind of is the most easiest product thing that we have worked on. And like you see, that's all is the amount of time it takes for the entire assaying to be done, it to enter the data, to get it sampled, to assay it, and to give out a printed slip. It just takes less than say 2 minutes. That's comparatively so low than the existing method, which is like 30 minutes, or sometimes it takes 3 hours also. And to just have a kind of understanding on what the technology is, because the theme to be a technology, I would be kind of stressing on this. So this is a cloud computing that is gone into it. And the reason for cloud computing is that there are multiple layers of people, multiple levels of people who needs access to the data, who needs data at different views, different type of data that they might need to access through, and in the different dashboards that would be needing. So it needs a kind of computing that has to be done on the cloud level basis, and this data would have to be viewed by the all the officials. And so for that matter of fact, cloud computing has to be put up in this. And yeah, in ML is machine learning. Machine learning was needed for the image processing to be actually done, and AI was done for getting up future insights on it. So we have not just worked around with one or two type of programs. We have in fact done 10 AI programs and 10 machine learning programs, so that to see what is the best. And through all this, we could achieve an accuracy of 98%. And the device is so smart, it is kind of improving its accuracy every day and day, because it's because of the AI program that we have built. And every day the accuracy keeps increasing, and the level of smartness of this device keeps increasing. It's like how your phone used to be before and it used to be now. The more you start using this device, the more smarter it'll start getting it. Then it's a image processing, because we would be majorly assaying on the physical parameters. Image processing has to be done, and every grain would be checked 360 degrees. Because this was achieved due to a non-impact action, which I'd be just getting back in a minute. So every grain would be achieved in the 3D image format, so that all the 360-degree view of a particular grain can be seen, and not a very bad result could be achieved with the assaying process. And very high precision sensors have been put up in it to get all these things done. So ideally all these is what put up, and then it would be going into the machine learning programming, and then it be pushed into the cloud computing for the official to see what is just the overview of it. But at the end there's a lot of process, and then it will also be a battery operated. So even at the remote location where there is no electricity that is needed, so the device can just be taken up and just put up in the place, and the assaying could be just done then and there. And non-impact section is another USP, which has to be done kind of so that the samples do not get destroyed, then the farmer do not get any loss due to it. And to see how these technologies kind of work around is through the small map that is there. So for image processing, you need kind of a high-end speed cameras that needs to capture data, and there are few sensors that would also be catching a few parameters that would be sent to AI beds and ML beds that is in the device itself. So the device, because of the sophistication in this device, and because we understand that most of these APMCs would be in remote locations where there might be even trouble to have a 2G signal, or even a smaller network range. So so the computerization, the optimization, and the processing has to be done at the device level. So from the device level itself, all the process would be done through a special beds that we have put up, and all the AI and ML programs are fed into it, including with the processing port. And right with the device, even without the need of an internet, it would give you the results out. And after it comes back to an internet position, the messages would be sent. But a farmer, if there is at a no network position, the printed slip was an option which we have added. And after he comes back to a range where he's in a network, all these data will be pushed up in a cloud, and this won't take up much time, and there won't be any delays in that. And it's battery operated, and there's a BMS unit to optimize the battery usage and cloud computing. It's just a technology overview of it. And this is how the printed slip would look after the assaying is being done, which would contain most of the parameters. And to have a more small to see what how we have been recognized among the peers, and how we have been recognized with the government. We were the winner of last Elevate in 2020, and government of Karnataka was kind enough to us. So we were among the 100 startups that were selected in Karnataka for last year. And obviously NIAM, who is one of our kind partners, and very what to say, very hand in hand partners, who's holding us and seeing us grow along. So, and we were also one of their agri incubation incubatee, and we are happily with them. And in business perspective, we are at the moment doing 30 APMCs in Karnataka. We started this in a joint venture with a collateral manager recently, and we are doing 30 APMCs from last month. And out of 50 is what 30 we have got, and we are looking at growing this numbers up also to a national level. And opportunities that we are looking at with this technological model is that we know that, and everyone knows that with quality and certification, there would be higher price for the grains, specifically for grain commodities. And with this particular thing, since the assayings are done kind of faster, it could be a huge opportunity for say KSMB or warehousing departments or NAFED, that specifically for them to purchase the commodities at these assayed values. And then the high volumes of commodities assayed, the high potential of earning. And ENAM is also one of the opportunity that we are kind of looking into, wherein because they are the most of the procurement agency, most of the APMCs are under them. So ENAM is one we are also registered traded. So we would also look into partnershiping with ENAM, because our portal is kind of API enabled for ENAM. Since we see that ENAM would be a futuristic prospective client. And since ENAM intends to bring 600 plus markets, and there are to the additional 500, it would be a huge growing opportunity for us along with ENAM. And this is kind of also one more important USP that we're looking at: quick assaying during MSP operations. So during MSP operations, though the quality of the grains might be compromised up and then, through this methodology, wherein the assaying could be carried out at then and there. And with the new ordinance that has come up through the government, wherein the trading should not just happen under the APMC Act, but it could be extended out also. Through this, though, if a farmer is in a remote location, and uh, if he wants to um, if he wants to say get his assayed, and if he's in a remote village, and these type of devices can actually help him to go in directly there and get it assayed. So, like I said, the new ordinance. So, what would happen is the doorstep assaying could be done, because a farmer at his village might not have the access to the labs, and these could also be enabling the farmers to sell at a proper, and the procurement agency do not have to compromise at these standards. And business model, we are currently working on two business model. One is with B2G, which is for government bodies and for private bodies. For government, we are kind of plan to give the device at free of cost, and then we would be charging them on a subscription basis. And then for private bodies, we would be giving out at as a smaller price for the device, and then kind of take us a service charge back from them. And we'd also be giving out them a custom modified backend so that it could ease their operation process also. So footprints, what we say is, so the impact what we would be causing to the society is that the faster the assaying is done, the faster the farmer can sell it, and there will be more demand for the product that he assays. And the farmer, if he gets the better price for us, he would be happy and he would be start cultivating the same thing again and again. And through our process, the transparency is increased and it reduces malpractices in the system. So we are at moment also have been giving rural employment, wherein a youth who knows to use a phone can operate a device, so they don't need a special degree or special training to get a saying done through our device. Even a youth who know to use a small phone can start using a device and be an assayer. So it kind of impacts rural youth employment also. And the farmers are kind of happy for what they are. And nothing can go better without a team. So these are the leadership team. It's founded by Dr. Santosh, who's also on the call today. And then that's me, and then Vamshi, who's taking care of the image processing. And yeah, so that's all from me, and that's all about three stack labs and how we use that technology. And I thank you, and I would like to just see the questions that are there, and I would like to take up questions from the audiences too.
So thank you, Manjunath. Now I request all the participants to unmute their mic and raise their questions one by one. You can also write your questions in the chat box. So one question from Rameshwar Kanwar. How many farmers were the beneficiary of this technology? What was farmer satisfaction?
So, Mr. Rameshwar, so to say farmers are, so with what farmers we have done and we are currently doing at 30 APMCs. So with the interaction with farmers, they say that this fast there is no technology that is available. And plus, because people are losing time in sampling, we are just giving the assayed values done then and there. The farmers are kind of happy because they don't have to roam around and see where the things are there. So that's the level of satisfaction we have seen at the farmers. Though there are some what do you say, some differences in some farmers, but not majority of the people have resistance to this particular technology.
Uh, so what is the accuracy level of your machine as compared to the conventional model which they are
So
using?
we, like I mentioned, it's close to 98.5 is what we are coming up right now. And like I said, the machine is a AI based machine, and as it is improving, it comes to 99% maybe in a month or so with the amount of data that we are pushing into it. And 99 is achieved. That is more than sufficient than the physically what they are doing it right now, because human errors are more worse than machine errors.
More question from Dr. K. Madhu Babu. What is the awareness percentage in general among farmers? So this question is more relevant. Like as you are saying that you have 30 APMCs, you are working in 30 APMCs in Karnataka. So how this awareness about this machine can be created like pan India level, or like how it will be more done at in even in Karnataka, because 30 APMCs you have just started with.
Yes. So, yeah, Abhishek. So, uh, Dr. Madhu, to just give you a brief understanding, so we are also doing it in a place called Shimoga, wherein the farmers and the commission agents are not even aware of the benefits of assaying. So, the major thing that comes up there is arcanut, and the farmers are not at all aware of how much impact an assaying could do for them. Though, right from commission agents to traders to also the farmers, because arcanuts, beetle nuts to be precise, are kind of expensive. And what happens is these farmers are very much denial to even give assaying samples to us. And we had to, at the current moment, we have to explain individual farmers, and we had to bring down the secretaries also to explain it to them. So awareness among the farmers are low, not very low, but it's kind of low at locations. But government is also pushing up, and it's kind of made it mandated. But with this manpower, what is currently there, it's not at all possible for all farmers to be aware of, and it is not possible for most of the farmers to even achieve the assaying that is done.
So one more question, like might be a repetition of questions. So what is your expansion plan?
Expansion plan, we are looking at going in pan India. So like I said up in the opportunities, so NAFED is one we are very much looking at, and we are also looking at in tie up with the ENAM. Kind of NIAM is very kind in helping us and getting that connection to us, and NAFED, ENAM, and through MSP operation we're also trying to expand it bigger.
So any more questions from audience? One more question, Manju. Like what cost it will be like per assaying? How much will be the farmer has to pay?
Farmer at moment is not paying anything, but at the current government is willing to pay 60 to 70 rupees per assaying, and this is based on a tender model, but based on a tender model, but through our assaying we can bring it down to 5 rupees.
Okay, and how much it was charged like as per the traditional model as
60 rupees, 60 rupees or 70 rupees. It depends from the collateral manager. It will be based on a tender process. The collateral manager will be bidding a price which the government will accept, which is the lowest, and that is somewhere between 60 to 70 rupees. We can do it at 5 rupees.
so basically who are your competitors at this right point like now?
There are quite a few who are kind of doing it, but I would say that they are trying to solve the problem. Like I would not like to mention their names at the forum, but there are a few who are there who are kind of trying to get there, but I have not looked at the point of what they have to be. So the whole purpose was to eliminate a lab and get up right then and there. If that is the case of a handheld lab that we are doing, or a handheld assaying machine, we could be the one. And but there are others who are doing it as a lab based devices.
What future upgradation with respect to technology advancement is planned?
There are a lot, in fact. So at moment, it like you say, it takes around 1.5 minutes. So we are trying to put in new data like TPU, which is tensor processing units into it, which would reduce it down to 1 minute, because there would be more sophisticated hardware that is going into the device. Along with that, the AI model would be upgraded in the future, and plus with that, the more number of grains that it can assay will also be added into it. So these are what we have been seeing. Along with that, we are also seeing into mapping with the existing farmers. You know, a farmer has a plot, and every farmer has a plot, and he can check the, and we want to have a satellitary image of these farms, and then we would like to check the asset quality of what he had before and what he could sow it in the next, and we want to have a kind of advisory solutions in that also.
So what about feed like as you already said that what about the feedback of the farmers as the feedback of the farmer is quite good. So
So, if I have to say, most of the farmers we have interacted, I have not even one farmer who I've interacted have told that this may not be good for them. So that's what it is, and most of the farmers are kind of welcoming at this point, and they need to be aware of, and this awareness can be only got through the government agencies, because many farmers are not even aware of what assaying could be and if they have to trade it in a yard or not. If you can,
so any
so
name if you can any name if you can share to us which we can relate this.
So relate this as in, if you're looking for competitors, I would like to not name them, but there was one session also through the same webinar that was handled by the same webinar, but there are few lot that is there. Yeah, I would like to not name them actually because it's not fine.
So, any other question from audiences?
S
So, I will just sharing your number and as well as email ID, Manju.
I think there is one more question that I need to take up.
Yeah,
So, do you
please.
think this product will encourage reverse migrants to take up agriculture in a big way? Will this also help them in getting employed? Yeah, so this is a primary so agriculture used to be the backbone of India, and people have left and gone back to other jobs because they were getting exploited in the system. Though they put in a lot of hard work, they were not even getting the money that they were needed for. If a farmer gets a proper quality check and if he gets a price for what he is sown, he would obviously return back, which basically means that if there's a transparency in the system, people would obviously turn back to this agriculture, and it could be a huge impact if those type of scenarios are happening. And that is what is the whole vision is. We want reverse migrants to take up agriculture, and we want to first clear the process out so that people will get encouraged to take up agriculture and they get to do what they want to do, because you do a hard work and you don't get anything for it, there's no point for you to continue with it. And that is how the agriculture is kind of going down in the country. For promotion.
Any other questions from audience?
So I, uh, so for to answer Mr. Ravi Kumar, yes, we are doing, but we are kind of in a stealth mode at the moment. Uh, we would be obviously giving it up once our final product is being launched, and you could follow us in LinkedIn and on Facebook, so you will get an update on that. Yep.
So, any more questions from audience?
I guess not.
I have shared the mobile number and email ID of Manjunath. You can connect with Manju with the email ID and mobile number provided to you. And so, I think it's time to conclude the session. And thank you, Manju, for
Ye-
this wonderful session. Like through your technology, a farmer can definitely get a better remuneration as compared to past. So better prices encourages farmers to grow more produces, and this assaying device can provide instant results and instant and reliable results. And the price of existing assaying machine, as you discussed, is rupees 60, and as you are charging rupees 5. So as I saw, a 90% 90% of the amount is saved for the farmers or for the APMCs. So ultimately, the burden of the farmers is reduced in terms of outflow of money. So with the help of your technology, definitely a farmer can definitely increase his production, get a better results of his whatever the results you are providing about the foreign mixtures and add mixtures, and as compared to the traditional machine which the we are providing, the results will be the product will be going to the labs, and then the labs are providing the results might be in a day or two. So the time you are saving for those farmers is really quite appreciable. And with the help of this, definitely this is the future of Indian tech. This is the future of Indian agriculture. This technology will definitely give a great help to the farmers and to the mandis. I wish you will be connected to uh, many more mandis in Karnataka and whole India. So my wishes to you. So now I once again I thank you, Manjunath. Your presentation really provided us with great insights, and your experience in sharing invaluable experience in agriculture technology. Participants really got benefited from your talk. So thank you once again. So at last, I would like to thank everyone for connected with us. And our next webinar will be on Thursday, 27th of August, 2020. Thank you.
Thank you,
Now you can
Abhishek.
leave the
Thanks everyone.
meeting. So, Sachin, please save the recording and save the chat as well.
Yeah, okay.
Thank you.